What's going on, guys? Tom here, and in today's video I'm going to be teaching you how to create your very own first-person controller in Godot. So let's get started. The first thing we're going to want to do is open Godot. So I'm running 3.1.1. We are going to create a brand new project. I'm just going to call this FPS tutorial 1. I'm going to create a folder here. OpenGL 3.0 is fine. Create and edit. Okay, so here we are in our Godot editor. We're going to choose 3D scene from the top left. Now, I'm going to be going a little bit faster than I did in my Make Your First Game in Godot tutorial because I'm assuming you've watched that. If you haven't, please go back and watch that. It covers all of the fundamentals of the Godot user interface, the scripting language, and things like that. So go back and watch that. I highly recommend it. Come back to this. We're going to be moving a little bit faster. I will be explaining things as we go, but like I say, it will just be at a slightly faster pace. So we've created our 3D node here. We're going to call it world. It's just something I like to do. The next thing we're going to do is we're going to create our player object. So to do that, we're going to press add child node. We're going to type kinematic body, and we're going to rename this to player. Now we need a collision shape for the player, and to do that, we're going to right click, add a child node, type collision shape. And here we're going to define the shape for our player, and the shape is going to be a capsule shape. Typically in first-person games, the player would just be a capsule collider because it sort of roughly represents the shape of a human body. Now you'll notice here that this doesn't really represent the shape of a human body. It's sort of sitting on its side. It's a bit fat and chunky, so we're going to make some changes to this. To do that, we're going to come over to the right-hand side. First, we're going to choose the transform, and we're going to change the rotation degrees to 90 on the x-axis. That just sort of makes it stand upright, which is great. And the next thing we're going to do is we're going to click on capsule shape here, just where it says shape. Click capsule shape, and we're going to get some options for this shape. I'm going to change the radius to 0.75, which just makes it sort of thinner, a little bit smaller. And then because we've made it smaller on the radius, we want to up the height a little bit, so 1.25. And that just sort of gives us a nicer shape to work with, I think. You can change it to anything you like, but I quite like working with this shape. The next thing we're going to do is we're going to create a head for our player, and the head is going to be where we put the camera. It's sort of going to be where our eye level is. So to do that, right click on the player, add a child node, and we're going to this time use a spatial, which if we look down here, it says the most basic 3D game object. It's the parent of all 3D related nodes. It basically just means an empty object in space that has a position and a rotation and things like that. We don't really care about displaying anything for the head as such. We just want an object that sits in 3D space. So we're going to choose a spatial, press create, and we're going to rename it to head. I just like to move this up to the top of the player hierarchy. I don't know why, it just feels logical to have the head sitting at the top of the player hierarchy. Next thing we're going to do is we're going to add a camera to that head. So we're going to right click the head, add a child node. This time it's a camera. So we've got this camera here. You can see it's pointing forward there. It's sort of pointing along on the z-axis here. So I'm going to click on the head, and I'm just going to move it to where it looks like the head should fit within this capsule collider. So we're just going to move it up, sort of like 0.9 on the y-axis. So roughly about there is fine. The next thing we're going to do is we're going to right click the player, add a child node. And this is completely optional really. I just like it because it helps you visualize the player a little bit better in the scene. So I'm going to type mesh instance. In the mesh option over on the right here, I'm just going to choose capsule mesh. I'm going to click on the mesh, choose a radius of 0.75, and choose a height of 1.25. And in the transform just down here, we're going to rotate it 90 on the x-axis. Now this just gives us like a solid capsule that we can visualize within our scene. It really doesn't affect gameplay at all. It doesn't have its own collider. We're still relying on the collision shape here. But I just like having this available because when your scene gets quite busy, it's sometimes quite difficult to see this very thin sort of mesh here for where your player is. So I just like having this about just to make it easier to visualize the player. Okay, so that is basically the structure of the player. The next thing we're going to do is we're going to create some ground for him to collide with. And in order to do that, we're going to right click on our world, add a child node, and we're going to say, let's just say mesh instance, and we're going to create a cube. Just create a simple cube, cube mesh. We'll move it down a little bit because we're going to be wanting to test gravity later on. We will scale it on both axes. In fact, actually what we'll do is we'll just scale it on the X and the Z axis there. We don't want to make it bigger on the Y axis. And in order to create a collision shape for this, there's multiple ways. You could right click, you could add your own collision shape, but sometimes it's easier just to click the mesh button up here just above the 3D view, press mesh, and you can create a convex collision sibling. So if you click on that, it creates a collision shape, and I just like to drag it just underneath. Again, you can do it other ways. You could click on the mesh, you could press create convex static body, and that will sort of create this nested hierarchy. Either way works, or you could create a static body and a collision shape. You don't even have to have the mesh. Completely up to you, but for now this will work. I'm going to rename this to ground. Alright, so that is pretty much it. I'm going to save this scene really quick, create a folder, call it scenes. It's already called world, press save. And just to make things a little bit cleaner, we're also going to create the player scene as well. So we're going to right click the player node and press save branch as scene, create a folder called player, and we'll just save the scene as the player scene. Okay, so we've got our ground, we've got our player. The next thing we need to do is we need to start programming this guy. So we're going to click into the player scene. We're going to expand our nodes here just so that we've got a clear view of what's going on. Let's zoom into our player character here. We're going to right click on the player and we're going to attach a script here. We're going to leave everything as default. It's going to create a player.gd script, and we're going to press create. So if you've watched my previous video, you'll know that you can export variables from a script, and that basically allows you to modify them in the inspector window on the right hand side. So just let me bump up the size of the code here just so that it's easier to read if you're watching this in a smaller YouTube window. What we're going to do is we're going to export 4 variables. They're going to be the speed of the character. For now, let's just say 10. They're going to be the acceleration of the character. We'll say 5. They're going to be the gravity that is affecting this character. We'll say 0.98. We're going to export the jump power of the character, and let's just say 30. Now, all of these values I'm just plucking out of thin air. We'll tweak them as we go. As we start to get familiar with how our player controller handles, we can come in and tweak the individual settings and, refine that as we go. But for now, these numbers will be fine. The next thing we're going to do is we want to respond to keyboard input. We want to respond to the W, A, S, and D for moving the player around, and we also want to respond to the spacebar for being able to jump. In order to do that, we're going to have to make some modifications to our input map. And we are going to go to project, project settings, input map, and here we're just going to define 5 more actions. So they're going to be move underscore forward, move underscore backward, move underscore left, move underscore right, and jump. We're going to assign these keys, W for forward, S for backwards, A for left, D for right, and finally spacebar for jump. Okay, so we're going to start responding to these inputs now, but there's a few things we need to do first. We want to get access to the camera object, because what we're going to do is when we're moving the mouse around, we're going to actually rotate that camera, and we also want access to the head because we're going to rotate the head as well. We can say onReady var head equals, and then we can say $, and this basically says I want to get access to a node that is in my current hierarchy. So this hierarchy on the left hand side here, the player hierarchy, I want to get a node inside of that. Now you notice it's auto populated here, so I can get the collision shape, I can get the mesh, I can get the head, and I can get the head camera. So I'm going to say we want the head, and we also want onReady var camera equals $head/camera. Now the onReady basically means when all of the objects, all of the nodes within this scene have fully loaded, assign this variable to that, which is a better way of basically saying func ready and, you know, assigning all the variables inside that func ready function. Okay, so we've got access to our head object, we've got access to our camera, we've defined some variables for the speed and acceleration and things like that. So we're ready to start implementing our actual movement code. So to do that, we're going to define a func for the physics process. We're going to say var direction equals vector 3. So basically we're creating a brand new vector 3 object, which we're going to populate with information based on what the player has input with the keyboard. So we're going to say if input dot is action pressed, and we're going to say move forward. So if they press the move forward button, then we want to say direction. Now what we want to do here is we want to add the forward vector to our player's direction vector. But in order to do that, we need to know what forward is. And forward is basically the direction that the head is looking. So we're going to do one more thing here. We're going to say var head basis equals, and we're going to say head dot get global transform dot basis. Now this is going to get us the head's current transform object, and on that there is a basis object, which basically is its local transform, so the local rotation axis and all that sort of stuff. So we're going to basically get that for the player's head. And what we can do here now is we can say direction plus equals head basis, so head basis dot, and then we want to say, I think we just want the z. Yeah, we just want z. And actually, forward in Godot land is negative on the z-axis. So we're going to say direction minus equals head basis dot z. We're going to do something similar for if we want to move backwards. So elif input dot is action pressed. We're going to say move backwards. Then we want to say direction plus equals head basis dot z. Now we're going to do similar for left and right. So we're going to say if input dot is action pressed. Notice I've started a new if statement here because we want to be able to move forward but not backwards at the same time. We want to be able to move backwards but not forwards at the same time. But we do want to be able to move forward and left, or forward and right, backwards and left, backwards and right at the same time. So these are two separate if statements here. Now we could just change this to an if, but you're never really going to be moving forward or backwards at the same time. They'll cancel each other out, so it doesn't really matter to have this as an if else. Is action pressed here, so we want to say move left. This time we want to say direction minus equals head basis dot x. Else if input dot is action pressed, move right. I want to say direction, let me just scroll that down here, direction plus equals head basis dot x. Okay, so if we save that now, we are basically saying that we've defined the direction that we want our player to move. Now there's one thing that we do need to do here, and that is we need to normalize the vector. If we don't normalize the vector, what's going to happen is if you're pressing forward or backwards, it's going to be fine. If you're pressing left and right, it's going to be fine. If you're pressing forward and left or forward and right, basically two different directions at the same time, you're going to be moving faster than if you were just moving in one direction. So to do that, we're going to say direction equals direction dot normalized, and that's just going to normalize the vector so that it's got a length of 1, I believe, is what normalization does. So let's save that. The next thing we're going to do is we are going to want to move our player. Now to do that, we're going to define a variable at the top here, and we're going to say var velocity equals vector 3. So we're going to keep track of a constant velocity for our player, and that is what we're going to use to move the player. So down here, we're just going to say velocity equals move and slide velocity. Now we need to assign velocity a variable, and to do that we're going to say velocity. We're going to say equals velocity dot linear interpolate. Now what this is going to do is we're going to start to move the player in the direction that we want to go, but we're going to do it at a rate that sort of speeds up, reaches its max, and then slows down again when the player takes the input away. So when the player starts pressing the W key, it's going to ramp up to a speed that's the max for his movement speed, and then when you let go of the W key, it's going to slow down gradually to a stop. Now, we can change all of that by tweaking the acceleration variable to get a natural feel, but it's basically just to stop the player from immediately starting to move and immediately stopping again. It just makes it feel a little bit more natural. So what we're going to do is we're going to say we want to linearly, I can't even pronounce that, linearly interpolate to our target vector, which would be our direction multiplied by our speed. So we want to go to our direction multiplied by our speed, but we want to do it at a rate that is our acceleration multiplied by the delta, which is the time taken between frames. So that just gives us a frame independent way of moving there. So if we save this and we come over to our world, we press play, we're going to select our world scene. You'll notice now that if you press W, you go forward. If you press S, you go backwards. A, you go left. D, you go right. And you can move in diagonals as well. And you'll notice that there is a nice sort of smooth movement going on here. You're not instantly jerking forward and then jerking to a stop when you let go. There is sort of a little tiny gradual acceleration and deceleration, which is great. But you'll notice that we can't move around at the moment. We're only locked to this one sort of direction. So we're going to fix that now by enabling mouse movement. To do that, we are going to define another function here. We're going to say func underscore input, and the input takes an event. And here what we basically want to say is we're only interested in whether or not the mouse has currently moved. So to do that, we're going to say if event is input event mouse motion. So what we want to say is if this event is the player moving their mouse, then we want to respond to that. Now what we want to do here is we want to say head, well we've actually got a reference to it here, so we want to say head dot rotate on the y-axis, and we want to say degrees to radius, and we want to take our event dot relative dot x. Now I know it says rotate y here, and we're saying relative dot x here, but that is because if we move the mouse left and right, which is the x-axis for the mouse, we actually want to rotate our head around the y-axis. Now you'll see why in a moment. We want to multiply that relative x by some form of sensitivity. Now I'm just going to put 0.3 here, but actually what I'm going to do is I'm going to export a new variable here called mouse sensitivity. Sensitivity equals 0.3, and let's place that in there. Now if I save this and if I run that, you'll see now that if I move the mouse left and right, we're rotating left and right, but it's actually inversed. So if I close that, I actually want to say negative relative.x. Let's press play again, and now you'll see that if I move my mouse right, we turn right, and if I move it left, we turn left. And you'll also notice that when we do our directions now, it's actually going in the direction that we're looking, which means we can walk around this entire platform, which is great. But we can't currently move up and down, so we'll fix that now as well. What we want to say here is we want to say camera.rotate on the x-axis deg to rad minus event.relative.y. So if the mouse is moved up and down, Then we want to rotate the camera on the x-axis. Again, we want to multiply that by the mouse sensitivity. We save that, and now if we press play, you'll notice that we can look down, we can look up, we can look left, we can look right, and everything appears to be working correctly. But there's an issue here. If you notice, we can move beyond sort of vertically down. We can sort of look back on ourselves, which is not great because then everything becomes inverted. And obviously this is not natural for a first-person controller. So we're going to fix that now by closing this. And to do that, what we're going to do is we're going to need to keep track of the angle that our head or the camera is currently looking at. So I'm going to create a new variable here called camera XRotation. And I'm going to start that off at 0. Now, what we want to do here is we don't want to rotate our camera if it's going to push us beyond those boundaries of basically 90 degrees either side. So what we're going to say is we're going to say var var, let's call it x delta. So the difference in x. And we're going to say that is event.relative.y multiplied by our mouse sensitivity. So basically this portion here. And we can change that there to x delta. And what we want to do is we want to say if our camera x rotation plus the x delta, so if our current rotation plus whatever we're just about to move it by is greater than or equal to, greater than minus 90, so we're going to clamp this to negative 90 degrees and positive 90 degrees, which is directly vertically up and down. So if the change is going to be within those boundaries of 90 degrees, then that's fine. And we also want to check that it's the other way as well. So if x delta is less than 90 degrees, then that's fine. We can rotate our camera, and we also want to say camera x rotation plus equals the x delta. So just to explain that again, we're going to say how far do we want the mouse to move? How far of an angle do we want to move by? Is this going to push us outside of that negative 90 and positive 90 boundary? If it isn't, then that's great. We can basically say rotate the camera, and then we're going to increase our local camera x rotation variable by how much we changed it by, just so that we can keep track and not go over that negative 90 and 90 boundary. We'll press play, and you'll notice now that if I look down, we can't get past that 90 degrees, and if I look up, we also can't get past that 90 degrees there, which is great. So now we have full control of our camera with the mouse. We can go left, we can go right, we can go up to 90 degrees, we can go down to 90 degrees, we can move forward, we can move backwards, we can move left, we can move right. And you'll also notice that if I look perfectly down and move forward, we go at the exact same speed as if we looked forward and moved forward. And that's great because it means that our code down here, which is using the head basis, is working fine. Now, if I change this here to camera, get global transform basis, now you'll see an issue here. Everything appears to be working okay, except for the fact that we'll start looking down and things go a bit awry. We look down even further and we're going super slow. The velocity starts to go all a bit weird, and all of a sudden we're flying off the earth. So that's not great. So we'll change that back to head. The final thing in all of this is we can just walk straight off here and nothing happens. There's no gravity, and we also didn't implement the jump. So we're going to do that now. I'm just going to make this code ever so slightly smaller just so I can see a bit more of what's going on. Now, to implement gravity is really, really simple. I can basically say where I'm assigning my velocity here, all I need to do is say velocity.y, and we're going to say plus equals our gravity. We're going to save that. Press play. Whoop. You see what's happened there? We've actually got the inverted gravity. So what we want to do is close that. We want to say negative. So minus equals gravity. Press play. And now you can see there, just press play again there. You can see that we drop. We land on the platform. And if I move off the edge and turn around, you'll see there goes the platform. We've fallen off the edge. Brilliant. Final thing to do is implement jumping. Again, really quite simple. We want to say if input dot is action just pressed, jump. Then we want to say our velocity. So velocity dot y equals, plus equals our jump power. I'm going to save that. Press play. Press the space bar, and you'll see that we can now jump. It's quite smooth, and we fall back down to the ground. We can go off the edge here, jump. You'll notice there's an issue here though. We can keep tapping space, and oh, I can infinitely jump. So final tweak here is that as part of this move and slide, if we go to the documentation for this, you can see that basically it accepts a floor normal vector. Now what that allows us to do is if we specify that floor normal vector, we get access to a couple of really handy functions. And I'll show you that in a second. So we're going to pass in this floor normal vector. To do that, we're going to say vector3 dot up. And now what it means is we have access to this variable called isOnFloor. So we can say and isOnFloor. So if we just press the jump key and we're currently on the floor, then we want to allow the player to jump. So we press play, we press space, we can jump, keep tapping space, and we can only jump after the player has hit the floor again. If we come off to the side here and we jump off, you'll notice that we can no longer jump back up. We're constantly falling. There's one final thing that we can do, and that is to lock the mouse to the window so that we're not getting this strange issue where, you know, the mouse is unlocked from the game window and we can move off and all of a sudden the game's not receiving input anymore. To do that, it's really quite simple. We can say at the top of our script here, func_ready. And we want to say input.set mouse mode, input.mouse mode captured. Save that. We can also, in our process here, which we don't currently have, we can create one, func_process delta. We can say if input.isAction just pressed, and we can say UI_cancel, which is the escape key by default. Then we can say input.set mouse mode visible. And that's just going to mean when we press the escape key, it's going to unlock the mouse again. So press play. You'll notice that our mouse cursor has gone from the screen. And now we can move as much as we want with our mouse. And it will never escape the window boundaries. And if we press the escape key, the mouse appears again and we can exit the game like that. And that's the basics of a first-person character controller here. Let me just zoom out of the script here just to show you that actually it's really not that much code at all. Let's go into a normal sized font here. So we have our extend from kinematic body, which just means that our player is a kinematic body, so we're going to control its physics through code. We're exporting a few variables here, our speed, which is 10, acceleration of 5, gravity of 0.98, jump power of 30, and a mouse sensitivity of 0.3. Again, you can tweak all of these by coming into the player node here, clicking on player, and you'll see on the right hand side that we can change all of these variables. So you can tweak these to your heart's content, make your character, faster, slower, reduce the effect of gravity, reverse the effect of gravity, make them jump less, make them not be able to jump at all. You can tweak all of that with these variables here. We're getting access to the head and the camera node within our hierarchy here. We're creating a velocity vector that is constantly being updated depending on our input. We're keeping track of the camera's X rotation so that we don't go outside of the 90 degrees boundaries. we're capturing our mouse input to stop the mouse exiting the window. In our input function, we're checking for any mouse movement. We're rotating the head on the y-axis based on how far left and right you're moving the mouse. And for the camera looking up and down, we're taking the mouse's y-axis, which is up and down, moving the mouse up and down. We're locking it to that 90 degrees, positive and negative, and we're rotating the camera's x-axis there by whatever that is. And then we're also making sure to keep track of the camera's x-rotation. In our function process here, this is simply just to be able to show the mouse again when we press the escape key. And in the physics process here, we are getting the current direction of our head object. We're taking the movement keys and we're applying a direction to that. So we're getting the direction that our head's currently looking in, and based on whether or not you press forward, backwards, left or right, we're taking the appropriate heads translations for that. We're normalizing the vector to make sure that if you press forward and left, forward and back, or a combination of keys, it's not becoming a larger vector, so we're not being able to move faster diagonally and things like that. We're linearly, I still can't say that word, linearly interpolating our velocity based on how far and how fast we want to move by our acceleration variable, which just gives us that nice smooth in and out motion when we start and stop. We're applying some gravity. We're checking if the user can jump and if they've pressed the jump key, and if so, we're applying some jump power there. And then finally, we are assigning the value of the move and slide function to our velocity. That basically just means we want to move and slide by the velocity that we currently have. And if we collided with something, then it's going to give us back a modified velocity. So it's going to, stop us from going into a wall. So we assign the variable, we assign the value of that move and slide function back to velocity. This final piece here, this vector3.up, is basically saying the ground normal is the up vector, so check for collisions in that direction, and if we hit one, then that's going to give us access to the is on floor. It's also going to give us access to a bunch of other things as well, but currently for now we just really care about this is on floor. And that is it. That is part one of this FPS tutorial series. We now have a first-person character controller that can move around. It can collide with the ground. We can jump and it's affected by gravity. And we can also set various variables to modify how that character controller moves and things like the mouse sensitivity. In the next tutorial, we'll look at adding some raycasts into the player so that we can start doing some raycast physics there for firing weapons and things like that. So I'll see you guys in the next video. Hope you enjoyed this one. If you did, leave a like down below, leave a comment if you're stuck with anything or you think I missed something, then leave that comment down below. Make sure to hit that subscribe button if you're not already subscribed, and I'll see you guys in the next video.